Did you know that before humans invented the wheel, we mastered something far more intricate? Knots? Today, we're untangling the fascinating history and science of knots, from prehistoric tools to cutting-edge mathematics. You'll discover how these simple twists of rope launched a mathematical revolution and why they're still crucial to modern science.
And what's really incredible is that knots have been fundamental to human survival and progress for thousands of years.
Let's start at the beginning. How far back can we trace the history of knots?
Well, archaeologists have found evidence of knot tying dating back to prehistoric times. These weren't just simple ties, they were sophisticated tools for survival.
That's fascinating. So, we're talking about one of humanity's oldest technologies?
Exactly. And what's particularly interesting is how knots became deeply embedded in different cultures. For instance, in ancient China, they appeared in artwork dating back several centuries BC.
Oh, really? Tell me more about that cultural aspect.
Well, take the Celtic monks who created the Book of Kells. They dedicated entire pages to intricate knotwork patterns. These weren't just decorative, they held deep spiritual significance.
That's incredible. But when did knots start becoming interesting to scientists and mathematicians?
That's actually quite a fascinating story. The first mathematical perspective on knots came from a French mathematician named Vandermonde in 1771.
What did Vandermonde have to say about knots?
He made this really interesting observation that while you could measure a knot's dimensions, what really mattered was how the threads were interlaced. It was about position, not measurement.
That sounds like it was ahead of its time.
It absolutely was. But the real breakthrough came with Carl Friedrich Gauss in the 19th century.
Gauss, the famous mathematician?
Yes. In 1794, they found drawings of knots among his belongings, along with a fascinating system for classifying them using letters.
How did that system work?
He would label each crossing point in a knot with letters and then record the sequence you'd encounter while traveling around the knot. For example, the simplest non-trivial knot, called a trefoil, would be written as ABC ABC.
Ooh, that's actually quite brilliant, turning a physical structure into a mathematical sequence.
And here's where it gets really interesting. In 1867, Lord Kelvin came up with a rather unusual theory about atoms.
What was his theory?
He proposed that atoms were actually knots tied in a substance called ether. Different knots would represent different elements.
Wait, he thought gold and oxygen were just different kinds of knots?
Exactly. Now, while that theory was completely wrong, it actually led to something remarkable.
What was that?
It inspired mathematicians to develop formal knot theory, which has turned out to be incredibly useful in modern science.
So what exactly is mathematical knot theory? How is it different from regular knots?
In mathematics, a knot is defined as a closed loop in three-dimensional space that can't be untangled into a simple circle without cutting it.
And how many different kinds of knots are there?
Well, according to recent research, mathematicians have tabulated more than 6 billion knots and links since the beginnings of knot theory.